So today we're going to be doing problem 26.38. In this problem we have three different charges, a 1 nanocoulomb positive charge, a 2 nanocoulomb positive charge, and a negative 2 nanocoulomb charge as well. It's set up in this triangle formation at 60 degrees for each corner. And the question is asking us to find what the force is on this top charge up here. To do that, the first thing I'm going to do is separate the problem into these two, how they interact, and then these two. So I'm going to label this one number 1, this one number 2, and this one number 3. And first I'm going to find the force of charge number 2 acting on charge number 1. To do that, I'm going to use Coulomb's law. And it comes out to 1.8 times 10 to the negative 4th newtons. Now, looking at the symmetry here, they are both 2 nanocoulomb charges, and they are both positioned the same distance from the 1 nanocoulomb charge. So I know that the force of number 3 on 1 is going to come out to the same. So they both have the same force acting on 1, just from different directions. So now, looking at number 1, I know that it's being pushed in this direction, and I need to split it up into an x and a y component. The x going this way, y going that way. And for charge number 3 acting on 1, it's being pulled in this direction. And that's what its components look like. Now, just going off of symmetry, I could tell that the y component of this one and the y component of this one are going to counteract each other, so I don't even need to worry about those. Also off of symmetry, I know that they both, in the x component, they both push it to the right, and they're going to have the same magnitude in the x direction. So all I have to do is solve for the x component of one of them and then times it by 2. So looking at this one, the x component is going to be the cosine of 60 degrees times 1.8 times 10 to the negative 4th newtons, which comes out to 9 times 10 to the negative 5th newtons. This is the x component of the force. So I also know the same over here. And now I add them together, this one and this one, and it comes back to, the total x force comes back to 1.8 times 10 to the negative 4th newtons. So to bring it all together, this is our 1 nanocoulomb charge, and it's being pushed to the right with a magnitude of 1.8 times 10 to the negative 4th newtons. And that is the answer to the problem.